For this problem, as we read through it, I suggest we draw a sketch to help us solve it. So an object is shot straight up from 10 meters above ground level. So if this is the ground level, this object is being shot here. That's 10 meters from ground level. It's shot straight up. And it has an initial velocity of 20 meters per second. Okay, and then just from our experience with free fall, we know that it's going to reach a highest position and then it will come down again because of gravity. Okay, so if this is our initial state, state 0, and this is our intermediate state, state 1, and this is our last state, state 2, we need to determine the total time it takes for this object to return to the ground if the effects of the air are neglected, which means that we only consider gravity, and also what is the highest position it has reached at state 1. Okay. So let's write down what we do know and what we need to find out. We know that this object has an initial velocity, VO, that is 20 meters per second. And we also know its initial position, SO. If we choose ground to be our reference, which is an obvious choice, then SO is 10 meters, positive 10 meters. This is by assuming this is our positive y direction. And then, what else do we know? We don't know the time, t1, but we do know that v1 is 0. v1 is the velocity of this object when it is at the highest position. At that point, the velocity is 0. And we do not know what S1 is. What is that highest position? We do want to find out. And we do know the final position. The final position is 0 because eventually it has come down to the ground again. We do not know what V2 is. What is its final velocity? We don't know that. And we do not know what T2 is. But there's one more piece of information that we do know, which is the acceleration. Because we only consider gravity, therefore we have constant acceleration. AC simply equals to g. On Earth, it is about 9.81 meters per second squared. However, if you noticed, I have chosen upwards to be my positive direction. Therefore, because acceleration is always straight down, that's going to be a negative 9.81 meter per second squared. So that's what we know and what we do not know. And what do we need to find out? We need to find out T2, which is the total time for the object to return back to the ground. And also we need to find out S1, which is the highest position. And we know that we can apply 3 equations to any 2 states. So if between the initial state and state 1, we can apply 3 equations, which are V1 equals to VO plus ACT1, S1 equals to S0 plus V0, T1 plus 1/2 ACT1 squared. And lastly, v1 squared equals to v0 squared plus 2 times AC S1 minus SO. So we can apply these three equations between state 0 and state 1. These three equations apply to constant acceleration, which is what we have now. So let's evaluate what do we have and what we need to find out. We realize that this equation right here is the best one because we need to find out what S1 is. And we do know VO, V1, AC, and SO. So in this equation, we have one unknown, but all the other four parameters are known. Therefore, that seemed to be an obvious choice. So the next thing to do is simply plug in the information. V1 is 0. V0 is 0 squared is still 0. V0 is 20 raised to the second power plus 2 times negative 9.81. S1 is our unknown minus S0, which is 10. So after we have done that, we realize that there's really only one unknown and that it can be easily solved from the equation, and that is 30.4 meter. So that's the answer for the first half of this problem. For the second half of the problem, we again can apply the similar three equations to, again, any two states. We can apply these three equations to state 0 and state 2, between state 0 and state 2, or between state 1 and state 2. So because of what we're given and what we need to find out, I have decided that the best equation for me is going to be this one. S2 equals to S0 plus V0T 2 plus 1/2 ACT2 squared, which is similar to this equation, but it's between state 0 and state 2. So why did I choose this one? Because I need to find out T2. T2 is my unknown. So in this equation, T2 is an unknown, but I realized that I know all the other parameters. I know S2, I know SO, VO, and AC. So I choose this equation for that reason. And I can now plug in all the known information. S2 is 0. This equals to SO is 10 plus VO is 20 times T2, which is not known, minus is actually plus 1/2 times negative 9.81. That's why I wrote minus earlier, T2 squared. So this equation is a quadratic equation, but do not let that scare you. There's only one unknown, and you know how to solve quadratic equation. You can try to factor it. If you can't, you always have the quadratic formula. So if you apply the quadratic formula, it will give you two answers, one positive, one negative. In this case, realistically, time should be positive. Therefore, we take the positive value from the solution from this quadratic equation, and that's going to be positive 4.53 seconds, because we eliminate the negative root. So in my opinion, to solve this problem, these two equations that I chose, so this one and this one, these two are best options because in either one of these two equations, I only have one unknown, so I can solve that one unknown from the equation without solving multiple equations. But doesn't mean that you cannot try other methods, and you should get to the same answer even if you do not do exactly what I did.